All right, this is Mrs. Martinez, and we are looking at graphs of linear equations in this video. Our objectives, what you as students want to be able to do, is to identify the slope and the x and y intercepts of a line, to interpret slope as a rate of change, to graph linear functions, and lastly, to convert linear functions from standard form to slope-intercept form. So let's get started. A linear function is a first-degree polynomial whose graph is a line. And below you'll see two examples of how a linear function might be written. It could be written y equals, and then notice we just have a polynomial here with the highest degree being 1. It's negative 3x plus 4. So you don't have exponents in these types of functions. It'll just be x with no exponent. You could write that same function using function notation, f of x. So that is a linear function. Standard form of a linear equation will always look like ax plus by equals c. And there's a specification here. A, b, and c are integers, meaning they are 1, 2, 3, 4, -1, -2, -3, -4. In our example, we have the standard form of a linear equation, and it's 3x plus y equals 4. Just a little addition to this. When it's in standard form, that a value has to be positive. So if you'll write that down in addition, that a value has to be positive. Just like R3 is a positive. If it wasn't positive, you would need to change the signs of all the terms so that your leading term would be positive. This form is really great for graphing. If you were to use that graph, finding the x and y intercepts, and we're going to do that in this video. It works very well. Here we go. So we have this equation, this linear equation in standard form. It's 2x plus 3y equals 6. And we want to graph this line in our Cartesian plane. Now what I was just saying is that this is really a good way. If you find your intercepts, you'll be able to graph it very swiftly. To find your intercepts, by intercepts I'm talking about your x and y intercepts. Where is your graph going to cross your x-axis, and where is your graph going to cross your y-axis? Well, to find your x-intercept, it's where your y value is 0, because on that x-axis, well, all the y values at any point are 0. So in this case, if our y value was 0, you'd have 2x equals 6, so x must be 3. Similarly, we find the y-intercept by letting your x equal 0. Because on your y-axis, the x values are 0. So if you plug in a 0 for your x, you'll have 3y equals 6, which means y is 2. And then you'll just draw the line between those points, and you have graphed a line by its intercepts. Let's do another one like this. Now this is, we're graphing negative 3x plus 4y equals 12. So the first thing to do is find those intercepts. Because it is in standard form, it's easy to graph with finding intercepts. To find your x-intercept, let y equal 0. We're looking at that would give us negative 3x equals 12. So x must be negative 4. Then we'll find our y-intercept by letting x equal 0. So that first term will, if you multiply negative 3 times 0, it just kind of cancels, it goes away. So the equation you're left with is 4y equals 12. So y is 3 when x is 0. And then we'll draw the line through those points, and we have graphed a line by its intercepts. So that's a really good approach to take when you are graphing from standard form. It's very fast, so speed and accuracy are important. The steepness, or you could say the inclination of a line, is called its slope. Slope is how steep or how inclined a line is. And m is usually the variable we use to represent slope. Slope is the rise over the run, or delta y over delta x. Delta meaning, change. The change in y over the change in x. So to find the change, it would just be the difference of your y's divided by the difference of your x's. So we're going to find the slope of this line. To do so, it's best to pick a distinguishable point like the y-intercept, or a point that doesn't have like a fraction. You want to find a point that is on integer values. So there are 2 points that are on integer values, and they're actually both intercepts. So we're going to try and move from one point to the other. We're going to move from the green to the red point. So we would be trying to find our rise over our run. You would be going down 2 and then moving positively to the right 5. So that's down 2, that means negative 2, and your run is 5. So that would be your slope. Now what if you didn't have a graph? There's a very good chance that you're just given some points like we have here. And we want to find the slope of the line passing through these points. To do so, we would use our equation. First we would label our points. I would say, okay, let this first point be x1 and y1, and the next point be x2 and y2. Then we plug those into our slope formula, and we would reduce. So y2 is negative 3, y1 is 5, so you're subtracting that 5 from negative 3. And then your x2 is 4, and then subtract your y1, which is negative 8. Notice, it's minus a negative. So that would actually be looking like 4 plus 8. That leaves us with negative 3 minus 5 in the numerator, and then 4 plus 8 in the denominator. That would be a negative 8 over 12. But both those numbers are even. They can be reduced. If you divide each of them by 4, that would give you negative 2 over 3. So your slope is negative 2 over 3. Slope-intercept form of a linear equation. Slope-intercept form is when it's in the form y equals mx plus b, where m is your slope and b is the y-intercept. So it's slope-intercept because you can very easily identify your slope and your intercept. Slope-intercept, I would know my slope and my intercept. The B, I like this alliteration here to remember. B tells me where to begin. And the M tells how to move. In our next example, we're going to see how that is very, very nice when graphing. So here we are. We have an equation in standard form, but we're going to do a little bit of algebra and solve for our y. To do that, you would first want to go ahead and move the x term over because we're trying to get y by itself. We're trying to isolate the y. And then, because if you were to read this, it's 2 times y, well, you'd have to do the opposite operation, so it would be divided by 2 instead of multiplying. And 2 can't divide into -3, so that remains a fraction. 2 divides into 8, and it gives us 4. Our equation is now in standard form. But no, I'm sorry, in slope-intercept form. But if we were to write that in function notation, we would write it f of x instead of using y. F of x is how you would write it using function notation. Now let's graph. When graphing, you want to first figure out where do I begin. My b value is 4. So that's what I will plot on my y-axis. And then I will ask myself, how do I move from where I'm beginning? Okay, well that is my slope, my m. It would be down 3 over 2. And from that point, that blue point, you could move down 3 over 2 so that you have a few more points. It's sometimes easier to line your ruler up and make a better graph. Using your ruler, you can draw a nice line through there. So that is graphing using slope and y-intercept.